my name is Patrick. Welcome to the demonstration of Chaincontext, a verifiable knowledge system for the Flare ecosystem. Chaincontext combines real-time FTSO data feeds with blockchain state information to provide trustworthy answers with transparent confidence assessments. The system runs in a trusted execution environment, a T, and provides cryptographic proof of secure execution through VTPM attestations. So, I'll explain the system architecture. Chaincontext consists of several key components. There's a data ingestion pipeline, which collects data from the FTSO feeds, blockchain state, documentation, and social media. Trust scoring mechanisms assign trust scores based on source reliability, recency, and cross-chain verification. All right, let's start. I'll show you the active services that are running. As you can see, there's an image for the pipeline, there's an image for Redis, there's an image for Qdrant, and there's an image for MongoDB. These are all connected to the pipeline in order to make the transversion of data possible. MongoDB stores the structured data and query history. Redis caches frequently accessed data and embeddings. Qdrant is a vector database for semantic search. All right, let's verify that the API endpoint is healthy. And there we go, we got an OK. Now let's verify that the symbols are available. And they are. As you can see, this is the FTSO data for the testnet. Notice the simulated flag, which indicates whether the data comes directly from the blockchain or is generated through a fallback system. In this case, there's a fallback system because I did not have time to fully integrate the data pull through. All right. We got a lot to see. The response should include the answer to the query, a confidence score indicating the system's certainty, a source with the trust scores showing transparency in information sourcing, and an attestation information that proves the answer was generated in a secure environment. So as you can see, here's the attestation information. As you can see, here is information as a response, and each with a trust score. They're all provided. There's no URLs because the social media is not fully integrated yet. As you can see here, this is how the trust score is calculated. So there's factors recency, there's source reliability, there's cross verification, there's on-chain verification, and then there's the base score for all the information combined. And then it combines everything combined with the weights, and then it builds up a trust score. This can be way more elaborate, of course. The more time I will have to implement this, the more elaborate and more secure it will be. So I think I already have a pretty good framework set up in order for this to be a very secure system. So for source reliability, for example, blockchain state is more trusted than social media. And for information recency, newer data is more trusted. For cross-verification, information confirmed by multiple sources gets a higher trust. On-chain verification gets the highest trust because it's on-chain and immutable. This makes the trustworthiness of information explicit and transparent. As you can see, the test begins by generating an attestation. The system is running in a Google Cloud Confidential VM with the AMD Ceph hardware level security and the VTPM support. The attestation is a cryptographically signed JWT token that contains verifiable claims about my execution environment. The token includes critical information like the hardware model, so the GCP AMD Ceph, and the software environment, the GCE, and the issuer, the Google's confidential computing service. Now you'll notice that when I try to verify the attestation on-chain, I get the error message. In a production environment, I would ensure the token verifier is properly configured on the contract, the VM is running the exact image expected in the contract, and the secure boot is enabled as required. With these conditions met, the verification would happen fully on-chain through the Flare VTPM attestation contract. Thank you for watching the Chaincontext demonstration. For more information, please go to the GitHub repo. Thank you very much.